Kia ora, Year 11 and Year 12. This is a request from Harry on trig proofs. So I'm going to do this question from one of the 2014 papers. Apologies in advance for the percussion in the background, but I can't do too much about it. So what we're going to do here is we're going to prove this identity. And we're going to work from the left-hand side through to the right-hand side. Now, very occasionally, we're going to go the other way around. We'll start on this side. But if you look at what we're trying to show here, there are some obvious things that we can do to the left-hand side. So we're going to start like this. What does it say on the left-hand side? Well, it says that we've got this expression, sine theta over 1 minus cos theta minus 1 over sine theta. We want to manipulate that so that we end up with 1 over tan theta. So we keep an eye on where we're going. Let's just change the pen. Now the first step here is to get a common denominator. 1 minus cos theta times sine theta. What do I need to do now? Well, I need to multiply the sine theta by sine theta, right? So I get sine squared theta, and I need to multiply the 1 by 1 minus cos theta. So it's going to be minus, in brackets, 1 minus cos theta. The next step is to expand out the brackets. So sine squared theta minus 1 plus cos theta. And down here I've got 1 minus cos theta sine theta. So this is quite a good point to pause and look at where I'm trying to get to. Remember that I want to end up showing that this is equal to 1 over tan theta. Well, 1 over tan theta is cos theta over sine theta. So if I look down at where I've got to, you can see that starting to come out. I've got sine theta here, and I'm going to want to have this factor simplify away. The other thing that tells me what to do next is that I know that the Pythagoras identity of cos squared theta plus sine squared theta equals 1 is the one that I'm going to use over and over in AS. So I can rewrite sine squared theta as 1 minus cos squared theta. And that gives me the next step. Okay, so you could just put that out to the side if you need to, right? Or you could just go straight to this next line. 1 minus cos squared theta minus 1 plus cos theta. And then we'll just leave that denominator as it is. Right, and you can see a whole lot of stuff is starting to simplify away. We're left with cos theta minus cos squared theta over 1 minus cos theta times sine theta. That equals cos theta into 1 minus cos theta over 1 minus cos theta times sine theta, which can be simplified to cos theta over sine theta, which is the reciprocal of tan theta. So that's equal to 1 over tan theta, and we're done. So that equals the right-hand side as required. Okay, so notice that I didn't end up working with both sides of the equation at once and ending up with something in the middle, right? We're not treating this as an equation. We're saying, let's look at the expression that we've got on the left-hand side, right? So the thought process is this: we're proving an identity, and we're thinking about this side and saying, what can I do with that expression to show that I end up with this expression? So we're not really saying that we want to equate them and then manipulate them and end up with a true statement. Okay, it's not quite the same thing. So the next part uses the first part. So even if you completely muck up that first part, to solve this horrible looking equation, what we're going to do is use the result above. So we're going to switch out this left-hand side for 1 over tan theta. I'm going to do that now, and I'm going to do something like this in the revision session on Friday, because I want you to see how useful drawing some graphs can be. Right, so what have we got? Well, we're trying to solve sine theta over 1 minus cos theta minus 1 over sine theta is equal to 4 tan theta. But we know from above that the left-hand side is simply 1 over tan theta. So 1 over tan theta is equal to 4 tan theta. 1/4 is equal to tan squared theta. Now, if I take the square root of both sides, I have to be careful to get both the positive and the negative ones. So tan theta is equal to plus or minus 1/2. And this is where I draw a graph and I look at what my domain is. So I'm told that theta has to be between 0 and 180. I'm going to take my ruler and mark in roughly where my solutions are going to be. So that's at, oh, something bad just happened. Where's my one note gone? There we are. So 2 solutions. A very rough sketch is going to help. You can see that we should have one solution here and one solution here, right? Because this is the value at 0.5 and this is the value at negative 0.5. So when I grab my calculator and I go theta is equal to tan inverse of 0.5 and I'm looking for it in degrees, I will get out 26.6 degrees. So that's great. That's that first value there. When I look at tan inverse negative 0.5, the calculator is going to give me this value back here, which is not in my domain. So what I have to do is to add 180 degrees onto it. So theta is going to equal tan inverse of negative 0.5 plus 180 degrees. And I find that doing the graph means that I'm not going to get confused with that answer, right? So don't just stop when you get an answer out of your calculator for that and you see that it's a negative number. So the final answer here will be 153.4 degrees. So there you go. I've got quite a few more questions like that we can look at tomorrow, and you can just email me if you've got any more that you want me to video. Thanks for watching.